better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
How are you, student? Hope you are doing good at home. So today, we learn with you together at home. I hope you enjoy the lesson. I hope you enjoy it. So today we go direct to the physics, subtopic on resistance. So resistance, you can ask yourself, what is resistance? Resistance comes from the word resistor. So resistor, what is resistor? So let's first of all learn from the word resistor. What is a resistor? Resistor is the device that is used to resist the passage of an electric current. Number one, it is a device. You have to state that it is a device that is used to block or to resist the passage of electric current. So we can say it is a device. So it is a device. I have to see the word, it is a device having resistance. It is a device having resistance to the passage, of what? Resistance, it is the passage of electric current, of the electric current. Now knowing that this is a device that having resistance to the passage of electric current, now I think you are well off to go. The second thing, ask yourself, do you know the symbol that is used to define or to state this resistance? Maybe you have ever had a chance in your spoiled radio at home. Maybe you have ever opened. Maybe you see things that look like this. They like cylinder-like form, and then that is a resistor. That is a resistor. It's a good example of a resistor. Maybe you have ever seen it. Now I can see you are remembering. That's very good. So the next thing, do you know the symbol of resistance? Do you know the symbol of resistance? Today I'm going to tell you, but tomorrow you are the one who is supposed to tell me. So the symbol for resistance is equals to, so the symbol that we use to refer to the resistance, we use this symbol. So that's the symbol that we use to refer to the resistance. Knowing that, I think we're ready to go. Now, you can have several resistors. Maybe you can be told, can you arrange the resistors in parallel form? So that's where we start now. So, in the previous lesson, we discussed the series arrangement. So right now, I want to go direct to the parallel arrangement. We go to the parallel arrangement. So, can you ask yourself, maybe you have ever had a maths teacher saying, parallel lines, these are lines that will never meet. For example, if these two hands, I can say they are in parallel arrangement. If anything happens, they will never meet. They will just go. They will never meet. So I hope you understand by the term parallel arrangement. So, suppose two vehicles are going on the opposite direction. They will never meet. But I see you are thinking, and whenever they have an accident, leave about an accident. That is my fault. But on the normal day, they will never meet. Two parallel vehicles, they will never meet. They are on the different lanes. This is going to this direction, this is coming to this direction. They will never meet at any point. So I hope now you understand by the term parallel. So, we have two two capacitors, and then arrange them into parallel. So for example, we have, that is the first capacitor, the second capacitor we have here, and then it is a circuit. You know, a circuit must be completed. You know that a circuit, you cannot leave it hanging. So you say it is connected to a 12 volts supply. And then this capacitor, no, this is resistor number 1. So we have C1, we have C2, this capacitor. No, just a minute, it's not a capacitor, it is a resistor. Sorry for that. So this is resistor 1, this is resistor 2. So, knowing that these are resistor, and then they are connected in parallel arrangement. They are connected in parallel arrangement. So, what are you supposed to do? What are you supposed to know? How can we get the total resistance? How do we get the total resistance? We know that the total resistance is equals to 1 over the R1 plus 1 over R2 plus 1 all over Rn, going that way. So, knowing that, can you note it in your notebook? That is a very crucial formula and a very needed formula when you are calculating the total resistance of capacitors, resistors that are arranged in parallel. So, my student, I ask you another question. For example, this is the first resistance, this is the second resistance, and then can you calculate the total resistance? I will tell you this way. Whenever you have two resistors, make a note, so NB. Whenever we have a two resistance, we can use this one, or we have 1 over RT is equals to, we are just having two resistance, is equals to R1 plus R2 all over R1, 2. This is where we have only two resistors. Only two resistors. It only applies where we have two resistors only. So, an example, knowing that, and you have written it in your book, I don't expect next time I give you a question, you get a wrong. Are you together, my students? So, example number 1. So, for example, you are given S. Resistor number 1 is equals to 12. What's the SI unit of resistance? SI unit of resistance is equals to ohms. So we can say the SI unit for resistance is equals to ohms. And the ohms is written as that way. Ohms. And then the second resistance is equals to 8. Is equals to 8. And then ask yourself, how can you calculate the total resistance? The total resistance, we say 1 over RT is equals to 1 all over 12 plus 1 all over 8. And then you get the LCM. The LCM is equals to what? The LCM, if you get it correct, is equals to 24. 24 divided by 12 multiplied by 1 is equals to 2 plus 24 divided by is equals to 3, which is equals to 5 over 24. And then you know that 1 over RT is equals to 5 all over 24. That's not the answer. Can you get the reciprocal of 1 over RT is equals to what? So we say RT is equals to, now you get the reciprocal, it becomes RT. You get the reciprocal, it becomes 24 all over 5, which is equals to what? Use your calculator and then you're going to see is equals to 4.8 ohms. 4.8 ohms. So knowing that, you can also use this formula to calculate at your own time. Use this formula because there are only two resistors that we have here. Now you can use this formula to confirm if you are going to get 4.8 as your answer. I hope you have enjoyed the class. What I challenge you, can you go and try to do more examples on the formula I've given you? You are not used here, but that's the assignment I've given unto you. I hope to see you next time. Thank you very much.